Hi, Dave here from MegaPoints Controllers. Welcome to the blog. Well, today's the day we're making some more of the stall Kato motor boards. So I've just made 25. Here's another stack of 25 boards. So I thought I'd bring you along and let you see what we do. We're going to make 25 more of these Kato solenoid driver boards. They're quite an easy board to make, fairly fast. And the first process is to apply solder paste to the top, and we do that using the stencil here, which is perfectly lined up on the PCB underneath. So let's dig out some of the solder. I use these pots of solder and my credit card tool. So a bit of running around today, there's all sorts of things going on. It's a typical Monday. Let's get some solder on the pot. Here's the solder. It's a bit like putty really. Of course it's lead free, so if I wipe this paste on, then I can wipe it off. And what we have is a board with solder applied. I wonder if I can show you that. See if you can focus. Give me some focus. Come on. There we go. So there's a solder paste now applied to all of those PCB marks where the mask allowed the stencil to allow the solder through. I'll just whiz through the rest. This will take a few minutes. Talk amongst yourselves. I hope all's going well with your model railways. We're busy. I've worked all day Saturday, all day Sunday. It's now Monday, it's the last Monday in January 2021. And we are beavering away, trying to keep up. What I do is I'll fill a board and then go through the rest until I've got all 25 with paste applied. And then we'll stick them through the pick and place machine. And if everything goes well, you can see what goes on. This isn't the most sophisticated stencil holder, but given the volume, given the number of different boards we have, it's probably the most flexible. And our dot pitch isn't so high that we can't do this. What's wrong with that? That looks weird. I think I might readjust this using the special readjusting method. There we go. So it moved between yesterday's batch and today's. Whoops. Scrape it on, wipe it off. The beauty of the stencil is I should have perfectly repeatable results every time. I know on the pick and place machine I've got to make a few adjustments to a couple of the components as they seem to have wandered. So you can see that as well. See how it works. Or how it doesn't. The joys of model railway engineering or manufacturing. People do say, why don't you just buy the boards in and get them made by a commercial manufacturer, but I'd rather keep my inventory as parts and make it as we need it. And when we do a small batch, we do generally 50 of a board at a time. So if this were servo controllers, I'd make 50. If it were multi-panels, I'd do 50. Or in this case, stall Kato drivers, of which 25 are downstairs having been finished and tested. And we'll just get on with the second half. Normally I'd do all 50 in one go, but for some reason, I can't remember why, we ended up splitting it. And I want to get these out the way because right behind these are a pack of CAN adapters. There's one tray. At this point there are no static issues because it's just a circuit board with nothing, no components on it. That's the halfway mark of these. When we were starting out, I was trying all different types of solder paste until I got the one that did the right job for us. This one finishes clean, doesn't need a wash. It's called a no clean solder paste and doesn't leave any acidic residue to attack the components. It's probably a bit more expensive, but works for us. If I was using a higher pitch microcontroller, then I'd have to be more precise in the way I apply solder, but for these it's not necessary. It's quite coarse. I hope from the angle the camera's at you can see what's going on. I've just stuck it on the edge of the bench. So that's 26 boards with solder paste applied. So what I'll do now is I'll just reposition the camera and let you see what happens on the pick and place machine. I said I'd try and show you everything, so before I move it, I'll show you the glamorous side of cleaning. It's an IPA rag. If you don't keep them clean, next time you use it becomes a problem. So it's basically alcohol. Well, that's the smell I'm getting. Alcohol wipe. Get the solder off. Okay. Right, I'll turn the compressor on and move the camera. See you in a minute. I think where the camera is now gives the best compromise for seeing it all. So here's my software. This is my job. These are all the components that are going to be mounted on this little board. This here is what the camera sees at the top. There are 3 cameras on this system, 2 down here looking up and 1 in the head looking down. I better give those a wipe before we start. I once spent ages trying to diagnose a problem where it was not correctly orienting parts, and after spending hours trying everything, I wiped the lens and it fixed it. So the way this works, I can drop the board in, and if I tell the machine to go to the fiducial mark 1, you see it's put the little cursor just over that little round circle. That's a fiducial, and here's the second. And what will happen is, when it sees the fiducials, let's see if I can show you here. Focus. So there's a round fiducial here and here, and what happens is the top head will locate these, and then it will make any small adjustments to do with, so that it can correctly orient the board, you know, taking into account for any jiggling or so on the pick and place machine. And from there it'll compute the offset of every other component on the board. So it's correcting for it. So I'll just put this back. And then if I've got this right now, let's just check. Got all the parts ready. This needs snipping. There's a few odd parts in here. It looks great with everything on reels ready to go, but the reality is quite different. If I put lots of this particular part, which are the H bridges on one after another, it doesn't pull the tape back properly, so I'll end up fixing that, as you'll see. So let's press go and see what happens. So it's looking at the fiducial. You can see this is what the vision system's determined, and it's produced an error. It didn't like what it saw. So let's see why. 0.8 should be 0.9. Try again. That should work. Camera off. So I've got to stand here and just peel the tape back from this part. It's placing the H bridges now. There are 6 on this. Now the side. It's these 3 going on the side that I think need a little bit of tweaking. I'll show you that in a minute when it comes off. I think this board takes about 1 minute 40 to make. So it's rejected that part. Okay, that's because it's cold. And I just need to keep kicking it till it works. How annoying. So it detected a vacuum of 17 kg5. So if I go West 5, first of all I want to put nozzle 2 in. So I'm going to tell it to pick nozzle 2. Pick nozzle 2. Then I'll say West 5 nozzle to feeder. So it's over the feeder now. Now the camera doesn't show it correctly because the camera is showing where the camera is, not where the nozzle is. They are offset. I could put the camera over, but that doesn't help. So I'm going to do a feed test, and then I'm going to do a pick to visual camera 1. West 5. Pick to visual camera 1. It's got the part. It's here. It's a small capacitor. Don't see anything wrong with that. Looking good. It's ever so slightly offset. So I think what I'll do, I'll just check the feeder alignment there. So West 5, feed test, and then I'll go nozzle 1. Now what I'm going to do, you can sit down, I'm going to manually drive the nozzle down and just check the alignment. So bring it down. You can see the nozzle moving down now slowly, moving towards the part. And I'm just bringing this down so I can see where it's hitting, and it actually is ever so slightly off. So, here's the adjustment, move it to the right. Maybe that was the problem all along. What I'm trying to do is just centre the nozzle over the capacitor. The smaller the component, then the more fun you have. When you change a reel, then sometimes the characteristics of the feed changes. Right, let's drive it into the spring. There we go. Now I can tell the system, relearn that. So I want X and Y and Z locations learnt. Okay, send it home again. Back to the part, this guy, start mounting here. Wish me luck. Yay! If I'm not my usual buoyant self, it's because I'm exhausted. It's middle of the afternoon, I've been working since 8 o'clock this morning. A lot of orders to get through today as well. Hopefully this looks okay. You can see it doing its thing. Because this is near a wall, I can't get the camera around the other side. It would be better for seeing it and me, but not to be. That's the voltage regulator going on. There's a diode. And I think now it's just the processor, which it's looking in the wrong place because I put the tray in the wrong place. There we go. Have another go. Hey, it's got one. Turns it round, has a really good look at it. So it's looking slightly more time because I told it to use a different algorithm. And here's the freshly assembled board. Hopefully it's in focus now. Now, the 3 integrated circuits on the right, let's see if I can show you these. Get it in focus? I noticed this one the other day. This one, and this one are just a little bit slightly too far to the right. So I'm going to adjust the machine to tell it to place them further left. And the way I do that, and I'll show you the result after on the bench, I'll fit a new board. Even though you think you're putting them in the same position, there are subtle differences. And I'm going to tell it now to go to the top of those 3 by saying move camera to part. And if you look here, you can see where it thinks it is. So looking at the board, the one in my hand, I want to move it left about half a millimetre. So let's put the adjustment on 1. I'll give it 6 stabs to the left. 1, 2, 3, 4, 5, 6. I don't know if you saw that move subtly. Now I'll relearn camera X, camera Y. Then we'll move to the next one. Camera to part. 1, 2, 3, 4, 5, 6. CX, CY, camera X and Y. And now to the next part. Move camera to part. 1, 2, 3, 4, 5, 6. And camera X and Y. Relearn those. Save it. And back home. And once it's made this board, I'll put the 2 side by side and you can hopefully see what's happening. Also, whoops, kicking everything, I didn't fit the rectifier to this board, and that's because I had a lot in another reel, so I'm going to return that on as well. Have I got a rectifier somewhere? There'll be one knocking about. Okay, so what I'm going to do is go to the part here, rectifier, and turn that on. So it's now going to place this part. If there's a tick here in this column, then it'll place it. So fiducials don't get placed and the 2 buttons don't get placed because they're manually put on. All right, I'm going to press the button. Wish me luck. Oh, that was great. Nothing happened. Let's have another go. Back round the back. Keep the tape feeling. 2. Right, the next one should be in the new position. Yep, looks better. The PCB footprint for these parts is really tight. There's very tight tolerances. I drew it myself and didn't allow enough, but it's fine. Just got to get it right. Let that jug away. It doesn't like that capacitor. I'm going to get another one. And the reason that's failing is because this particular feed is troublesome. I don't know why, it's very stiff. So if you don't give it a manual tug every now and then, have another go. Now it should be fine. Yep. So this is what the camera sees. This is what the vision system sees. So it's analysing it. And if it can see the patterns, it can calculate the offset based on what it's actually holding and then drop it down and it should be accurate. Is the rectifier going on? Big parts are usually easy, but not too big. Now for the processor. All those pins. Great. 24 more to go. Now before we do the next one, I'll just check this under the light. Yeah, I'm happy with that. It's probably difficult to see here, but try and get this in. These 3 ICs have moved left slightly and they're far more centrally positioned. That's true. Before and after. So the before is at the bottom, the after is at the top. These are just subtly, give me some focus, just a little bit too far to the right and it was annoying me. So hopefully that's going to be okay. Right. Clean the fiducials, ready, set, and we're off. Peeling this tape is such a pain. If it was placing different parts from the back row between each of these, I wouldn't have to stand here and do that. Look, hey, you work with what you've got. And there's another feeder playing up. I think the tape might have torn. Well, that'll be fun. Let's have another go. Close. Try one more time. Bit of tug. Nope. Okay, well I'll tell you what, I'll have that rectifier. Oh no I won't, I'll take this one for the first board because it was missing. Drop that on. Right, see how it's a daily fight. And try again. Ah yeah, the tape has ripped. Probably can't show you that. But it's just come apart from the side enough to block the path of the component. Now that's going to be fun to fix. Okay, not had that before. It's all good fun. What I think I'm going to do, I'm just going to part the head out of the way and we'll see if we can clean this up. Take the tape off. And I basically need to join or heal. Problem is I'm going to pull a lot of components out now. Yep. So I'll end up placing these manually. This is the tape that separates from the bottom, and that's what causes the H-bridges to require a bit of a tug. It's the thicker tapes at the back that seem to cause the problem, and it's usually when you have a lot of the same component one after another. Right, let's stick that back in there. See, I said I'd show you warts and all. It's all the stuff you don't see. People show you on the internet, hey, look at my pick and place, it's working great. Yep, it is. How much effort did you put into it? The answer is loads. Then again, this machine's been, I don't think it owes me anything. Let's just run it. Oops. So hard over the years. It does really work almost every day. Way more than it deserves to, I think. Right, let's cut these out. Oh no, I'll tell you what, I'll leave that out. I'll have these parts. So what I'm going to do now is take these rectifiers out and tell the machine to stop placing them, and I'll put them in by hand. What a mess. Still, beats working for a living now. them on the table, and I'll just say DB207 no. So we want to place the diode and the CPU. Start mounting here. Carry on. We can cut this off. And that. Right, try and get this production line flowing. Check the parts look good under the magnifying glass. Yeah, and go. Pulling the tape off again. Otherwise it just doesn't quite pull it off and it slips probably by about 2 millimeters every placement. We're looking good now. We've warmed it up. The compressor's used to generate a vacuum to drive the feeders at the back and the vacuum nozzle to pick the parts. Voltage regulator. Now we change nozzle, slightly bigger nozzle for the rectifier, for the diode, sorry. We change nozzle again, nozzle number 4. That's for the CPU. And it's done. And we rinse and repeat for 25 or 27 boards in this case. And if you look here, there's the time, 1 minute 28. Right, I'm going to move the camera now, see if we can get a better overall view. Back in a minute. Oops, forgot to pull the tape and it starts rejecting parts. There we go. I'll give it another start, carry on. Keep that running. Now we come down here. This is where the we fit the buttons and give it an eyeball before soldering. Everything looks good, looks great, parts are lined up. I'll put these into the oven in 9s. The rectifiers as well. So all I need to do is fit the rectifier the right way round. And drop the 2 buttons on. Hopefully you can see, you can see me as well. Woohoo! So there's the 2 buttons placed. The board's had an eyeball, everything looks good. And while I'm doing that, that thing's making a mess down there. Let's put the next one in. I'm usually a bit more organised than this. I think the camera's thrown me. And there's the phone. MegaPoints controllers, Dave speaking. Right. So So we're back in the room. That was a nice little phone call, turned into a nice little order. And we'll just wait for this to finish. I see the windsock thing on my microphone fell off again. Absolutely hopeless. Doesn't matter how hard you press it on or fit it, it just won't stay. I can feel the super glue coming out for that. Okay, hopefully that'll do. Next board. Next board, please. And go. Hold the back. Every time I forget, it stops. And waste components. There we go. And while that's running, I can fit the rectifier and the buttons. Looks good. As soon as I've got 9, I'll turn the oven on. I'll have to move the camera for that if you want to see it, so we'll do that in a bit. Sounds like it's done. And next. So about 1 minute 40, was it? Was it taking 1 minute 27? Make a board every 127. You don't see this on a real program. Or should I say, you only see this on a real program. Let's get it right. Okay. Rectifier on. Must get them the right way round, of course. And buttons. Putting things on straight is so much easier now. Everything looks good. And drop it in the oven. I'll run the oven a couple of times before I move the camera. You can get a feeling for the flow. How far back can you see? You can just about make me out the back. Okay. So I think I have what you describe as a love-hate relationship with this machine. Because when you're desperate to make something and it doesn't want to work, I want to chuck it out the window. I do have my eyes on a much larger machine with a conveyor belt on it. So you can feed the PCBs in from the left and it'll whiz them down, produce them and then squirt them out the opposite side. Problem is, I can't get it up the stairs. Keep my shirt off the feeders. Good. Get this one in and put the oven on. Rectifier. Button 1. Button 2. It's so much easier to fit these by hand than have the machine do it. So I can buy them loose in a pack like this, whereas if I had to have the machine do it, they'd have to come on a reel. and it'd be quite expensive then. Anything on a reel just seems to cost a lot more. Now the oven's on, I need to ventilate the room. It's -2 outside, so with the oven on we should end up at, what is it in here, 14 degrees. See, when it's going, it's great. You just have to get it going. Come on, there we go. Dunk. And park. One off. One on. I'm getting my stride now with the camera where it is out the way. So I just had a call from a chap, needed to know what he needed to buy. It's 2:20 now. I said if you get your order in by 2, that was 10 minutes ago, I'd ship it today. So we'll get these boards done and then we'll, if it's there, they'll go today, and if it's not, it'll go tomorrow. It's having a long think. That part just got rejected. Tell by the sound. Yeah, it's got that. The oven's on, up to 18 degrees. We've got a lot going on, as ever. My daughter's downstairs finishing the last batch of what could possibly go wrong, he said, famous last words. There's the alarm, that's telling me the laser wants me. So I'll let this run, then I'll go and attend to it. I'll bring you along, you can have a look. Okay, thanks. Let's get one more going. Right, so I'm going to pull the camera out and take you to the laser. I mentioned the previous order that just came in. So what I'm going to do is just print that out while we're at it. So I'll just prep this up. There's Lucy in the corner of the office. And she's been finishing this batch of the boards we're making upstairs, and she's just done a load of buttons. There's the workload. That's what we need to do in the next couple of days. So let's park the camera. Just come out of the office, just waiting for the order to print, and we can go to the warehouse, as we call it, and the garage where the laser cutter is. Attend to those and get those postal jobs done, then carry on back upstairs where we were before. Yes, orders in the making. Come on. If you've ever watched paint dry, I'm there now. This is because I'm trying to do something quickly. Yeah, hey. Oh, double-sided. Okay. Come on, let's have it. And the second side is blank. Brilliant. That's the one. Okay. Keep up. So I've just turned up in the garage. My alarm on my phone went to tell me we've just finished a sheet of servo mounts. You don't get much wood left, do you? Quite efficient. These are designed so that they don't leave any residue on the laser bed when they're finished. That means I can change them quickly. I never seem to get enough of these. We're always just keeping up. A sheet of wood. I'm going to turn that into 96 mounts. Sheet down. Test. Looking good. Laser on, da 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 da, go. And I can set the alarm now, give it another hour. I'll give it a bit longer. Hey Google, set an alarm for 90 minutes.
4:08 p.m.
Good. You can hear the one next door. So that's chugging away. So while I'm down here, let's go next door and just finish off today's orders. I'll bring you with me. So here we are in the post room. These are today's orders. I've just got this one to do. I always seem to run around like a nutter. Not another order. No, that's the one I've got in my hand. So, switch box for servo controller. Excellent product, if I say so myself. Tick. I think I can lose my jacket, as this room is heated. The other one isn't. Servo controller. They are here. Ooh, feel like we're making some more of those. And you get your cables. 1, 2, 3, 4. In this case though, the customer isn't going to need them because they're in the switch box. Eight SG90 servos. One, 2, 3, 4, 5, 6, 7, 8. Try and give them away there. 8 SG90s and a regulated power supply. And with that comes an adapter. So I think I'm going to put that in a medium-sized box. Just keep that together. Or will, yes, that'll fit in this. Let's see. Just check the camera, make sure I'm visible. I'm quite good at chatting away while I or the other bits aren't in shot. So we've got this, that can go in like that. Switch box here, servo controller. It's not quite going to fit unless, no, not going to do it. Okay, thwarted by a servo controller. Next one up, I can hear in the background the lasers cutting, chugging away on the other side. One day I'll show you the mounts being made. It just goes on. It takes. Actually, I backed the power right off on the laser, so it's taken about 90 minutes. Then again, my laser tube must be coming up for 4 years old. I haven't replaced it yet. I'm pretty impressed because it's in use all the time. Okay, we want a box for that so it doesn't get squished. One of these. Important, please read. By the way, there's a reason for that. Nobody ever does, but it tells you on there things that, if ignored, may save you some pain. Like, use the correct power supply. And there are basically, everything is 12 volt regulated, except for the solenoid board. They're old solenoids of design, so they want AC and they want 16 volts. Bit of oomph. Other than that, Everything's designed around 12 volts DC, which is much more modern. How can I get that in? Like that, like that. That's good. Servos. I can go in loose. Tick, 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 tick. And if I write the order number on the top, 839, drop that in, and we'll add some bubble wrap. I never used to go through a lot of this, and now I go through yards of the stuff. A reel like this at the top, I don't know if you can see it up there. Yeah, it's just about in shot, bits of it are. Might last me 2 or 3 weeks. Lovingly packed by Dave. Okay, seal that up. Oh, there's the top of the microphone. Declaring independence. Did I mention how this annoys me? I think I did. I'm going to get the souped up glue on that. Right. This is the last one for today. Last order for today. Right. Now, depending on how much you spent, our system will figure out and send it first or second or special delivery. That is 1220 grams. What was the order number? 8369. Come on, come on, come on. Time is money. 8369. Apply postage, and that is, this is click and drop from Royal Mail I'm using. 83 grams. 1220, 1220. So that will be a parcel. So it's 48 hour, so it's under £200. Go, apply labels. And hopefully we'll get a label. First one after the computer started, takes a while. There's our label. How convenient is that? There you go. Unknown customer, your order is almost ready. Now while we're here, as the orders are done, we'll get them in the sacks. Right, that's 24 hour. Very nearly as special. Any more 24s? No, 48's an international. So we get 24 label. And these will be picked up in about an hour's time. That's the 24s. We'll do the 48s next. Actually no, I'll do the international next. Even Ireland's international now. Just 2 of those. 2 international. And this needs me to write the date on it. The date today is 25th. Tracked 25th, 1st, 21, 1 of 1. That's the international for today. There'll be. Where's the alarm going? Hey Google, off. 24s, no, 48, sorry. Next, and that's almost everything else. And when they scan our manifest, at that point you'll get the it's on its way message, I think, because we ship them within, it takes about half an hour from when we create the label. Wow. Just a second, that's something else. today's second class tracked. Probably electronics is an ideal candidate for post, in that it tends to be reasonable value but small in size and weight. And that is classed as, that's a second class letter, so PPI. So it has to go in a separate sack. And we want PPI, printed postage, second class. If you don't label them right, Royal Mail get very unhappy. So that's the post done. I think I can close that. These sacks back. Keep about 40 sacks in spare. Anyway, I'll kill the camera for now. We'll print the manifests and then we can go back to making circuit boards. See you in a bit. So we've just finished cycling the first set of boards through the oven, and we'll swap them over and see what we've got. How hard can it be? 1, whoops, come back. 2, throwing them away. 3, 4, 5, 6, 7, 8 and 9. So I've run down, changed the wood over on the laser cutter for the servo mounts, put the post in sacks. That's all ready now with the manifest printed, waiting for Royal Mail to collect. And I just want to get these boards cycled through the oven and checked, visually checked. And tomorrow they'll be finished off, and then I can go and do something else, of which there'll be no shortage. There's the oven, in and on, and away we go. I did stop to make a cup of coffee. Where's my chair? So that'll take 15 minutes in the oven usually. Hello, can you see me now? There you are. Maybe while I'm here I should talk about my coffee cup. This was given to us, Sheila and I, matching pair, by Judith at Eileen's Emporium. There you go. Mine's got my name on it, so I know it's mine. Okay, let's have a look at these boards. Oh, it is a thing of beauty. Come and have a look. Focus, and there we are. All the bits are soldered on. So what we need to do to finish this is put the screw connectors at the top and the side, and put the pins on as well, and they'll all be hand soldered. And then we'll be ready to put some software on it and see if it works. Right. 1. 2. 3. 4. I don't know why I'm counting them. There's 25 slots. Looking good. Oh, I love it when everything looks good. This is where I find out I've done something daft. Like there's a component the wrong way round, and chuck them all in the bin. Cry. Thing is, at the beginning of the week I've got a nice schedule of production schedule of what we're going to make, and usually by the end of Monday that's on its head, and we are desperate to make something else because we've forgotten to count something. So this oven's chugging away. Let's talk about the oven. Haha, let me show you something. Where is it? This is the fluid that's in the oven. It's called Galden. This is 5 kilos. Now, think, 5 kilos, 5 litres. No, it's 4 litres. It's actually heavier than water. This stuff is so expensive. The 4 litres in this container cost me nearly, are you ready? Pull the arms of your chair up so you don't fall over. £1,000. There was not much change out of £950 for this. Apparently that's all the science in the oven. What happens is this LS230 sits in the base of the oven, and the oven will heat it. It's called a vapor phase oven. So it's not like infrared coming down. It's heating the liquid, and the liquid forms a vapor. It pushes the oxygen out as the vapor rises, and it melts the solder. And the vapor temperature of that is 230 degrees, LS230. So it'll rise. The thermometer will detect the temperature inside the oven. It'll run it through several profiles. Like, to begin with, it'll do an anti-tombstone. A tombstone is when you get a resistor, for example, lying flat, and one end wets before the other, and it can pull it up due to surface tension. And the idea is it brings the solder up just below its melting point, sits there for a while and lets the whole board come to a uniform temperature. And then it will, once it's established that, maybe it'll hold it there for 20 seconds. Then it will continue with the boiling phase and raise the temperature up to 230 degrees. It'll just pip the 230 degrees for about 5 or 6 seconds, and then the fans will come on and they'll start cooling the liquid. And when it's down to 60 degrees, see, I can put a glove on and pull it out. Let's see where we're up to now. So it's the preheat, and it's 46 degrees at the moment. So while that's happening, I'll rattle off some more boards. I'll move the camera. See you in a minute. Now we're back to bun fight at the OK Corral. Grab another circuit board. Let's finish these off. I've got 2, 4, 6, 8 to do. So that should be less than 16 minutes. And we're off. And this time I've got to remember to stand here. Just for the first 6 components. Oh, I forgot to tell it to place the rectifier. I'll change that in a minute. Right, let's prep some of these while we're here. Do them. These. Sorry, phone doesn't stop ringing. Right, next. Oh, it failed. Why did it stop? It stopped because capacitor. Continue. There we go. It's so much fun when you're trying to get into something and the phone rings. Customer support is important though. Now I only need to put the switches on. The noise in the background is the fan on the oven. It's cooling down. According to the oven it is. Oh, it's at 83 degrees now. So we can restock it as soon as these are done. And I'll move the camera so you can see that side of it once we've got these last 4 boards through the pick and place machine. Notice it's placing the rectifiers okay now, before the backing tape had split, or the front tape. Give these a haircut. Today's tape from the side. And we can turn the compressor off now. There we go, last component, and we're done. Board looks good. Get those 2 buttons on. 1, 2. Great. So we've got 8 to go in. Right. Going to move the camera again so you can see what's going on. Back in a bit. Where's my glove? So we'll take these out of the oven. Got 9 in here. 1,